We're back again, and we're again studying the inverse tangent or the inverse trig functions. And we are going to look at some typical problems simplifying expressions. Okay, so these are typical exercises that you should be able to take care of. For example, if you were asked the sine inverse of 1/2, what does that simplify to? Remember, we are asked to find the arc whose sine is 1/2. And so a quick glance at the unit circle will tell us that, let's see, the sines are the y coordinates. So we're halfway up on the y-axis, and we're at this location, pi over 6. So the sine inverse of 1/2 is pi over 6. And remember, because of the domain and range considerations, we will not choose 5 pi over 6, because the graph of the arc sine, as we saw in the previous lesson, the graph of the arc sine goes up only to pi over 2 and down to negative pi by 2. Okay, just that portion. And let's draw that graph a little bit prettier so that we actually have it going through the origin. Here's our axis xy, and the sine inverse graph comes up and comes down, and I still can't get it to go through the origin. How about right there? Okay. And so we have, this is at pi by 2, and this is at negative pi by 2, and 1 and negative 1. Okay, so the highest value that we can get for this question, again, we're looking at the question, what is the arc whose sine is 1/2? The highest value we can get is pi by 2. And again, recall that this is dealing with the right side of the circle only, the right side of the circle, and certainly pi by 2 up top, negative pi by 2 on the bottom, and pi over 6 is out of the range of the arc sine function. Okay, let's try another simplification problem. Let's find the sine inverse of 3/2. And so you say, okay, let's glance at the unit circle again. And you notice pretty quickly that the sine is the y coordinate moving this way, but the highest the y coordinate gets is 1 on the unit circle. So 3/2, that's impossible. So this problem, the sine inverse of 3/2, is undefined. That makes no sense whatsoever. Undefined. If you try it on the calculator, it's rather interesting. If you try sine inverse of 1.5, you get an error. It says error domain. And remember, domain is the input. You cannot input 1.5. The graph, again, verifies that. Let's go back to the graph here. You see the domain, looking at the graph of the arcsine, the domain is always stuck between -1 and 1. So if you choose a number like 3/2, that's outside of the domain. Not possible. Okay, so there's a simplifying a inverse trig expression. Let's try another page. We'll try another problem. Find the sine of the cosine inverse of the square root of 3 over 2. Okay, so that's a problem we're going to work, and as soon as you see the square root of 3 over 2, you suspect that this will probably be a standard angle. And sure enough, let's see, we want the sine of the arc that has a cosine of the square root of 3 over 2. That's what we need. Okay, so a quick trip to the unit circle. We know the cosine that, let's see, the arc that has a cosine of the square root of 3 over 2 is, again, this pi over 6 arc, right? The ordered pair there was the square root of 3 over 2, comma 1/2. So sure enough, we find that the cosine is the square root of 3 over 2, and so the resulting arc is pi over 6. So now we have the sine of pi over 6. Hi, Mrs. Baker. She just walked in and she's aghast that I'm talking to myself looking at a smartboard. But I will have Mrs. Baker go to my webpage and she will see the video recording of the inverse trig function lecture. I did see that article in the newspaper. We're flipping as we speak. So the sine of pi over 6. We're back to the video lecture, children. The sine of pi over 6 is in fact 1/2. Just look at the picture. The sine of pi over 6 is 1/2. Okay, so let's try another one. And obviously that was sorry about the diversion there. Miss Baker was coming in looking at what was going on. So this was one that dealt with a standard number, square root of 3 over 2. That's one of our standard angles and one of our points that we would recognize on the unit circle. Let's try one that's not so standard. Suppose I were to ask, what is the sine of the tan inverse of 2/3? Okay, so, and 2/3 is certainly a legitimate tangent value, but how that appears on a unit circle, I'm not sure. So once again, we need a sine of the arc that has a tangent of 2/3. The sine of the arc that has a tangent of 2/3. Well, I'm not going to go and draw the unit circle this time. This time I'm going to draw a right triangle. So here's a right triangle, and here's an angle down here. And this arc, when we say arctan, this arc can also be an angle. An angle. So let's see, we're looking for the sine of the angle that has a tangent of 2/3. Now you'll never see angle tan. It's always called the arctan. But you remember from early in the year when we were dealing with circles and we were dealing with arcs and angles, there was a nice little relationship that the arc length was r times the central angle, r theta, theta being in radians. And if this was a unit circle, then we would have s is equal to 1 theta, or s is equal to theta. The arc was the same as the angle. Okay? So that's what I'm claiming here, is that this arc and this angle are the same. And what we need is an angle that has a tangent now of 2/3. Well, we know our right triangle trigonometry. If this is the angle, the tangent was opposite over adjacent, and this angle now has a tangent of 2/3. Okay, so this portion of our problem is represented by that triangle. Now let's finish the problem. The problem says find the sine of that arc. Find the sine of the arc that has a tangent of 2/3. All it's asking is what is the sine of this angle? So you say, okay, I know how to do the sine of an angle. A sine of an angle in a right triangle is opposite over hypotenuse. This is the square root of 13. 9 plus 4 is 13. Take the square root. So the sine of the arc that has a tangent of 2/3 is going to be 2 over root 13. And yes, you should go ahead and rationalize the denominator. So that's 2 root 13 over 13. There we are. The sine of the angle that has a tangent of 2/3, the sine of the arctan of 2/3, 2 square roots of 13 over 13. Okay. Let's try one that's a little bit different. Now we're going to ask, what is the sine inverse of the cosine, sine inverse of the cosine, and let's pick 5 pi over 4. So here's your task. What is the sine inverse of the cosine of 5 pi over 4? Well, just like all algebra, we work with the parentheses first, and we first need the cosine of 5 pi over 4. That's a standard unit circle problem. We find there's 1, 2, 3, 4, 5 pi over 4. The ordered pair is minus root 2 over 2 and minus root 2 over 2. The cosine of 5 pi over 4 is minus root 2 over 2. Okay, so that's the parentheses, and now we're asked to find the sine inverse of that value. Okay, so not too bad. We once again think sine inverse as the arc that has a sine of minus root 3 over 2. And that's not hard to do. Another quick unit circle will give it to us. Now remember, the arc sine is only defined on the right side of the circle. So whatever answer we come up with, we have to be between negative pi by 2 and pi by 2. So the sine is negative, which says we're down here in quadrant 4. Remember, sine are y coordinates. And negative square root of 3 over 2 is quite a far ways down. That will occur right here, right? And the ordered pair being the square, let's see, the ordered pair being 1/2, comma, negative square root of 3 over 2. So sure enough, we do have the sine being the correct value. And now we need to know what this angle is. The angle is measured this way. And so the answer will be negative pi by 3. Okay? So the arc sine of negative square root of 3 over 2 is negative pi by 3. And that answers this original problem up here. Okay, so a little bit tedious with numbers. The last sort of the ultimate type of problem that you will see, let me pull up a new page. This will be my last example for this series. And this will be what happens if you have a expression instead of actual numbers. So let's see, I'm flipping through the text looking at some of the exercises. And here's an interesting problem. I'll do an even problem. You need to write the expression, okay, write the expression as an algebra, expression. So we're going to change this is going to be a inverse trig expression. We're going to rewrite it as an algebra expression. And the constraint is that x, algebra expression in x, with x being positive. So for some reason, we don't want to have x being negative. And here's a typical problem. What is the tangent of the arc cosine of x? And you say, wow, I don't even see any numbers there. All I see are some expressions. So once again, let's draw a triangle. And here's an angle down here. This is going to be the angle that's referenced right here. This arc is going to be this angle. And we know that the cosine of this angle has to be x. The cosine of the angle, and again, I usually put this angle down here in the lower left-hand corner of my triangle, is x. That's what that says. So let me rewrite this as the cosine of the angle is x over 1. I don't think you could argue with that. And then let's think about right triangle trigonometry again. Cosine is adjacent over hypotenuse. So x over 1, that's this right here. The cosine is x over 1. And now to finish this problem, we are going to need to have the other side of this triangle. So we need to have, let's call it A temporarily so that we can actually, we'll call it A so that we can use good old Pythagoras. we know that a squared plus x squared is 1. Leg squared plus leg squared is hypotenuse squared. So a squared is 1 minus x squared. And so a is plus or minus the square root of 1 minus x squared. 1 minus x squared. Let's go ahead and take the positive root for this because we're dealing with a right triangle, and we know legs of triangles aren't negative values. So our triangle now looks like this. We have an angle down here. There's my right angle. This was x, this is 1, and this is now the square root of 1 minus x squared. And so what we've done is go back to the original problem. We've taken care of this portion right here. We have a triangle that has an arc or an angle that has a cosine of x, x over 1, and we found the other leg is the square root of 1 minus x squared. Now let's answer the question that's asked. The question was, what is the tangent of that angle? What is the tangent of that angle? Okay, if I throw theta there just to use a symbol for an angle. The tangent of that angle is obviously opposite over adjacent. So the tangent of the arc that has a cosine of x is going to be the opposite side, square root of 1 minus x squared, over the adjacent side, which is x. And there we are. Notice that in order to do that, we had to do two things. We had to create the triangle to begin with. That was the first thing. We had to find the missing side, and then we had to answer the question that was asked. The tangent of the arc whose cosine is x is this value. And we get that by just looking at the triangle. Okay, so we'll do some more of these later. This will finish this little session. Have fun.